Hello everyone, my name is Carlos Morales. I run AI for Ambiq. So in terms of practicality, what are some of the things that you could do? And here I picked speech interfaces because wearables have an interface problem, like very, very small screens. Unless you're very dexterous, you can't, use that screen very effectively. It's hard to tap on this thing. So a lot of these devices are going to count on speech interfaces. Even when there is no screen, you could do speech interfaces. We're all familiar with the first one, which is keyword spotting. It's that OK computer kind of interaction. It's an AI that's just sitting there spinning, waiting for that phrase to happen. There's actually pretty sophisticated software that happens before and after. But it's been very, very optimized. So that thing, you can see, it runs that little kind of dotted line square is where most of SoCs operate. So keyword spotting, comfortable workload for that. Speech to intent is a really interesting model where instead of listening for a key phrase, it's listening for inflection and tone. It turns out when you say turn on the lights, there's a pattern to that. Like humans, we actually listen to the words. But if you have pets, if you have a dog, they're not listening to the words, they're listening to how you say it. And that's what this model does. It knows the shape of your intent. And it's, as an AI nerd, it's pretty cool how it works. It turns that speech into a picture using spectrographic analysis. And it does image recognition, the stuff that we talked about a couple of slides ago, on that spectrogram. And so it starts saying, hey, this spectrogram looks like somebody wants to turn on the lights. And humans, regardless of how you say it, lights turn on the lights, please turn on the lights, it's too dark in here, turn on, there's multiple different ways of saying your intent. The model kind of extracts that. It's pretty impressive stuff. And it's still something that you can comfortably do it uses a lot more power than a keyword spotter, but it's something that you can do comfortably if you have enough RAM and you have enough battery space. Speech enhancement is not a speech task, it's actually an audio task. So task is feature. What speech enhancement does is think of it as noise cancellation for everything but speech. So you put in noisy speech, conference room, multiple people talking, there's a leaf blower outside and you're trying to have a nice meeting, and it calculates the mask of everything but the speech, and it cancels the noise out. That one is more computationally intense because you have to look back over multiple seconds and it's a moving window. And so once you start running speech to intent, unless you have a very efficient power efficient pipeline, you'll be able to demonstrate it, but you won't be able to run it in a practical way. So speech intent, one of my favorite tasks. Looking a little further into the future, we start looking at features that require actual understanding of words. So this is the first kind of tier of AI where you start translating a spoken word into a textual word and then doing inference on those things. And this is useful if you're doing language translation, or you're doing a conversation with your device, or taking dictation, so dictating a message or something to your device. It's something that can run on I would say a phone with a lot of RAM and serious, maybe even a neural processor on it. It's because of the RAM limitations, I'm not seeing a lot of applications in the endpoint space yet. But remember the tailwinds. The researchers are making these things smaller, and companies like Ambiq are squeezing more and more compute and resources into small packages. So I think in the near future, we'll start seeing something in this space. So taking a step back from speech, I think speech is one of the killer apps. Of course, speech UIs, user interfaces, are very important for our constrained space devices. Activity recognition is another one. So activity recognition, every fitness band, smartwatch has some form of activity recognition today. There are some that are very difficult to do. Like it's okay. It's are you walking or running? Easy. You can probably do that with a simple model. Are you cooking or having dinner? When you're cooking or having dinner, those movements are very similar. Like you're moving your hands in the same kind of way. You're staring at a pot or shoving food in your face. Hard to discriminate between those two. So you need something called a complex activity recognizer. And the reason those are important is because cooking is a context. There are some things that you don't want your watch to do while you're doing something like cooking. Like you don't want it to. The last thing I want is my watch to recommend that I meditate or go for a walk when I'm in the middle of an activity where I can't do it. I would love my watch to know that I'm on a plane. Like, okay, you're on a plane, you're not going to stand up, right? So context is something that these very small devices often lack. It's very hard for them given their limited sensors. This, I think, is one of the, adding context to your wearable behavior is a killer app. And then you can fuse all these things, right? Now you have some context, you have a speech interface, and now the context is you're in a dinner party. Okay, during a dinner party, there's a lot of people talking. You want your watch only listening when you say, okay, watch, do this. If you're alone, if you're working out at the gym or something and there's nobody around you, so the context is you're alone, then just tell your watch to do something. And you don't have to say the okay watch. You skip that step. It's much more natural. It's how you would talk to a normal person, and we want our devices to feel normal.